Today, I'll be presenting our system for decentralized speed test, which is enabled by our proof of backhaul. A little bit about our team. Our objective is to develop proofs for decentralized infrastructure. Our team consists of researchers and developers from the area of blockchains, wireless networks, and cloud computing. So let me give you a brief overview of how speed tests are performed in the current setup. So what you have are centralized speed tests. The centralized speed test, all of you might have used. It's like Ookla or anything like that. They maintain very expensive, high-performance servers in all geographical locations. Now, what if you can replace that expensive servers with a lot of small, low-power servers running on decentralized compute platforms such as Filecoin Station? What you can do is now we can combine multiple low-throughput servers and aggregate that data and perform the speed test. Now, the main innovation here lies in the fact that you don't need to trust any of those decentralized compute servers. And that's enabled by our proof of backhaul. Once you have a proof that you have a certain bandwidth available at your node, you can perform a lot of applications. So that proof is available on FEVM, and you can enable other contracts that extract data from that proof. You can incentivize station nodes with high provable bandwidth. You can integrate this service for internet service providers. And you can also tokenize network and use those tokens for DeFi protocols, sell futures and derivatives. Going over a brief architecture of proof of bandwidth, you have a peer who pays to run the speed test. The speed test is run on a prover who is claiming a certain bandwidth, and it is run by a set of challengers which is randomly selected. Those challengers run those tests and then post it on our network proof contract, from which any FEVM contract can do a lookup and get to know the reputation, network reputation of a particular prover. Now, one thing I would like you to notice is that the proof of backhaul challengers are a perfect fit for decentralized compute. They're very simple compute jobs. They don't require any orchestration, and they don't require verifiable computing because we have redundancy or resilience built in within our proof of backhaul. So we'll go through a brief demo. Let's go ahead. So this is the Explorer in which you can see the set of online nodes. You can start a challenge, pay for it using Filecoin. And once the challenge is started, it will spawn a random set of challengers. These are like selected 4 challengers. It will run a test for less than a second and produce these results. These results will then be posted on the blockchain, and from which we gather this data, and it shows that this prover has a bandwidth of 100 Mbps. This can be used by other FEVM contracts in the future if needed. Right, thank you for going through our presentation. You can reach out to me on my Telegram, or you can look at our website and our publications. I would like to reach out especially to decentralized compute platforms who require demand for compute jobs, and also to anyone who needs network telemetry for their network. Right, thank you everyone.